Welcome everybody to today's webinar, the Introduction to Multifamily Passive House, presented by the Mass CEC. We've got Beverly Craig here from Mass CEC. Beverly, do you want to introduce yourself?
Hi everyone, this is Beverly Craig. Can you hear me?
Yes.
We work here at the Massachusetts Clean Energy Center, and we have been sponsoring a Passive House Design Challenge that is incentivizing 8 projects to build to Passive House standards. And so we are supporting this webinar today because when we looked out into what kind of training materials were out there, a lot of the Passive House materials were blending a lot of single-family and multifamily lessons and examples, and we wanted something that was nice and short for people just about the multifamily experience. So today we have Kate Stephenson. She is a partner in Helm Construction Solutions, which works with owners, designers, and builders to create high performance and sustainable buildings and businesses. She's an experienced leader in the fields of green building, professional education, sustainability, and business management. Kate is a Passive House certified builder and a facilitator for Nessie's Building Energy Bottom Lines program, which is a peer network for builders and architects. Kate is also the chair of the Montpelier Energy Advisory Committee and serves on the board of Nessie and the Vermont Council on Rural Development. Go ahead, Kate.
Okay, thanks very much, Beverly. So today our goal is really to give you a general overview of Passive House for multifamily buildings. And this presentation is really designed for all members of a project team, whether you're a developer, builder, architect, engineer. If you are relatively new to Passive House or you've done it on a residential or smaller scale, single family scale, this is an opportunity to learn more about what some of the aspects are for multifamily. And so what we did was actually go out and talk to members who have completed multifamily projects here in the Northeast, trying to understand some of the lessons learned from their projects. So today we'll look at some of the characteristics of multifamily passive house. We'll look at some case studies. And then at the end, we are planning to have 10 to 15 minutes for questions at the end. So you can use the chat feature of the webinar to quote, raise your hand and ask questions as we go. And so I'll keep an eye on that, but we'll also kind of queue up the questions for the end. But the first thing we wanted to do is just get a sense of who's in the room. So we just have a quick poll. And it's asking, what part of the project team are you? So we just want to get a sense of kind of architects, developers, trades folks, and general contractors. So feel free to click in. We'll just leave this up for a few seconds to get a sense of the types of folks who are here. Looks like we've got quite a few developers. Over 50% developers, 20% architects, 16% general contractor. Okay, great. Any last responses before I close? Looks like it's pretty much done. Okay. Great. Well, thanks everybody. That helps us just understand a little bit about who's here today. Okay, so let's get started. And so our first section is just to look at what are the characteristics of a passive house? What makes it different than what you'd be doing already? That really is looking at how do we minimize energy use, make it as very low energy use compared to traditional code. We're looking at a building envelope with continuous insulation on the exterior, typically, and solid air barrier all the way around. We're looking to optimize solar gain and use passive solar heating when it's appropriate, but we'll talk about that more. We're looking at continuous ventilation with heat recovery, thermal bridge-free construction, and really trying to create buildings that are highly resilient and can withstand, losses of power or extreme weather events. So those are some of the things that in general describe what a passive house is. And so again, when you look at like a building, this is just kind of a sample, but we often see high performance windows and doors, really managing solar energy both to maximize gain when you want it for heat, but also shading devices to minimize overheating in the summer. You see continuous insulation, thermal bridge free, and the fresh air with heat recovery. So compared to a typical existing building, we're looking for 90% reduction in heating and cooling loads. And this is not necessarily compared to a brand new stretch code building, but compared to existing building stock. Passive houses in general are seeing very large reductions in heating and cooling load. And when we do compare to Massachusetts stretch code, we're seeing 30 to 45% range of reduction in energy use. So you can see in this graph from New Ecology, this is the energy use intensity, or kBTUs per square foot per year. Stretch code you see is kind of in the high 20s to low 30 or high 30s, and then the middle bar is Energy Star, drops it, and then FIAS Plus, which is one of the passive house certifications, drops it down to about 20 kBTUs per square foot per year. So you see a significant reduction compared to stretch code. And also when we look at air tightness compared to the Massachusetts Energy Code, passive house air tightness is significantly lower. So that is one of the key things that when we talk about what makes a passive house, we're talking generally about space conditioning, air tightness, and then the overall source energy per person per year. So when we are looking to define what makes a passive house, there are kind of two components that I think of. One is really in the design phase, doing a lot of extensive energy modeling. There's different software out there that you can use to model your building, depending on which passive house certification you're using. But you're looking at things like annual heating, peak heating load, annual cooling load, and peak cooling load. And then, like I said, the total source energy per person. And so you have to be below a metric for total source energy per person. And then the other part about certification is actually during construction. So you're going to have third-party verification of that you've met all the criteria, that it is built as designed. You are going to have to show through blower door testing your air tightness during construction. And then we also look at compartmentalization. That is really part of Energy Star, but it is built into the FIAS Plus certification. And most projects are going to be going for Energy Star anyway, typically, no matter what certification path they're using. So, passive houses has this, one of the real values of the certification process is this third-party verification. It's not just saying that it's going to be low energy use, but it's actually showing it, and has someone else outside of your team coming in to look at the how it's constructed. So as I mentioned, there are two different paths for certification for a passive house building. One is through Passive House Institute US, often known as FIAS, and then the other is through Passive House Institute, which is the original German certification standard. They both are actively certifying projects here in the United States. And one of the great things is that looking at the numbers, we're seeing a huge increase in just overall certification of projects, but particularly in the multifamily space. If you look back 5 years ago, there were just a handful of multifamily projects that had ever been certified here in the States. And now we're seeing dozens and dozens of projects going through this process. So that's one of the exciting things. And we're really seeing some great, action in this area of multifamily. So this is a chart from FIAS, and it basically is just meant to show you a little bit of the kind of how FIAS Plus in particular compares to some other energy certifications. So if you, and we're just kind of looking at, again, like what are the different components that change when you compare to, say, 2009 International Code to 2012 code to just going through regular Energy Star, and then version 3.1 of Energy Star. You see that down on the bottom, the HERS rating slowly getting lower, and then as you go into zero energy home certification, FIAS Plus, and then the last column is FIAS Plus Source Zero, which means including photovoltaics to make your project net zero. But these all just show kind of the additional things that are required for on the quote performance staircase. So when we just step back and talk about like what are the reasons that it might be worth going for Passive House on a multifamily project, the first one is one of the big drivers is often lower energy costs, either for the landlord and or the tenants, depending on who pays the utility bills. We see significantly improved indoor air quality, and that has to do with the active ventilation. It has to do with reduced air leakage. So we see just incredible health benefits that are the result of improved indoor air quality. You also see very comfortable temperature controlled units. So there's a lot less fluctuation in different parts of the building because of the air sealing and the high insulation levels. So you'll see in some of the case studies, there's quite a few senior housing developments that have gone for Passive House, that one of the, they're really looking for comfort and good indoor air quality in those situations. You see real durability in the construction details. You often hear that Passive Houses are very quiet. Again, due to high performance windows, good insulation. I mentioned this earlier, but one of the benefits is resilience, the ability to shelter in place. And that really speaks to if the power goes out, if there's no heat in the building for a day or two, can the building still provide a comfortable temperature so that folks can stay there even in some kind of natural disaster or power outage. And then, big picture, why are we also doing this? Because we want to reduce our overall carbon emissions from the heating and cooling of our buildings, and we want to mitigate climate change. So that's kind of more on the big picture scale, but lots of benefits for going to the Passive House level for multifamily buildings. So when we talk about, when going out and interviewing lots of different teams that have been working on these projects, tried to kind of just encapsulate like what are the kind of top 10 things to focus on. One of them clearly is insulation. So, but one of the interesting things is that compared to a single family home where you may have heard that you need 2-foot thick walls and like R100 in the attic to meet Passive House, in these larger multifamily buildings, often the levels of insulation are not that significantly, aren't that much higher than what you'd be doing for code these days anyway. So the larger massing of multifamily buildings can make the insulation less of an issue, but still important and still one of the key things that's going to drive that source energy down. We also look at air sealing, and that's looking at minimizing leaks, cracks. They look very carefully at how to minimize penetrations through the building envelope. So we're really trying to eliminate as much as possible, exhaust vents, plumbing stacks, or trying to keep those to a minimum. And then having a really clear air sealing strategy for the envelope. On the HVAC side, one of the things that you often hear about Passive House is it's lowercase h, capital V, and then lowercase AC, and that's because ventilation is really the focus. But we often see, you see really low heating loads in these multifamily buildings that are designed to passive house standard. Often we're seeing the use of mini split air-to-air heat pumps for heating and cooling. There are other high efficiency heating options. One of the real challenges is that often the heating loads are so low that it's hard to find traditional HVAC systems that meet those loads. So we can talk about that a little bit more in the case studies, but there are a few different approaches to how to manage designing for super low load buildings. And then the ventilation, we always, requires heat recovery on ventilation, so you cannot just do exhaust only, but you're basically taking exhaust air from kitchens and bathrooms, and before sending the air out and exhausting it, you're capturing waste heat and using it to preheat incoming fresh air from the outside. So there are a variety of ways to do that: heat recovery ventilation, energy recovery ventilation. You'll hear those terms, HRV and ERV, used in a lot of these projects. Other areas that we tend to focus on include windows and doors, making sure that they are designed to really have a really good air seal. And you'll often see triple pane windows in passive house, although that's not required. Trying to emphasize casement awning or the European style tilt turn windows, because those tend to seal better than a traditional double hung or a slider. And often you'll see in these case studies the use of exterior shading, particularly on south and west facades. So that's something that's really to control for overheating. But it really depends on your site and the building design. One of the things you see in a lot of buildings is, trying to avoid combustion appliances entirely in passive house projects. So that usually means like no gas range or fireplace or wood stove. Those are not typically things you see in a lot of multifamily anyway, but really trying to reduce any indoor air pollution as a result of combustion. And then thermal breaks, that's where there are potentially materials that are continuous from interior to exterior, or places where the cold can travel through a building material. And so when you're doing the energy modeling for passive house, you see a lot of attention. You have to model all the thermal bridges in your assemblies and minimize those as much as possible. So let's look at a couple case studies. These are, again, from around New England, or the Northeast, I guess I should say. The images that you see in these slides are all from, most of them all from these different case studies that we've been following. So this is Elm Place, completed in 2017, 30 units of affordable senior housing up in northern Vermont. And this is a project with so some of the things that we tried to pull out in looking at these case studies are just wall assemblies, roof insulation, kind of looking at different ways that they approached the HVAC, heating, cooling, and ventilation. A lot of these do include a renewable energy component with solar, but that is not a requirement of passive house. Even though you see a lot of images with the PV, it's not required for straight up passive house certification. I know one of the challenges, I picked this image because after talking to the folks on their project team, they have parking on the lowest, ground level, and then the units above that. And that was definitely one of the biggest challenges for them, which creating a solid insulated floor deck above the parking and figuring out how to manage that. This is the Village Center project in Brewer, Maine. Also an affordable housing, 3-story project. Pretty traditional kind of low-rise multifamily construction with 2x6 walls, and then an interior. So it's basically a double stud wall system with cellulose. They, actually ended up using electric baseboard. They were able to bring the heating load so low that they could heat each unit with about 6 feet of electric baseboard per unit. And they had decided not to do cooling, and so that was the most affordable option. And one of the things that we talk about in terms of the ventilation strategies is also, are you doing what they call, one-to-one ventilation? Is it one ERV per unit, or is it a larger system that feeds all of the units? This is kind of a hybrid of both, where they're using one ERV, 3-to-1, one ERV for 3 apartments to just reduce the number of ERV units. Oops. This is Guilford Village Knolls, Guilford, New Hampshire. This was also an affordable senior housing complex with 24 units, developed by the Laconia Area Community Land Trust. This also pretty standard, kind of typical construction, again, low-rise multifamily, 2x8 walls with blown-in fiberglass, 6 inches of foam under the slab, and they used Mitsubishi 8-to-1. So on the mini split, they used 1 compressor for 8 units. And this has a pretty significant rooftop solar array that you'll see in some of the photos, going in all different directions on the roof. This is Beach Green North down in New York, also completed in 2017, much larger. You'll see 101 units, almost 100,000 square feet. And you start to get into kind of the different wall systems for larger buildings. ICF construction throughout, so insulated concrete forms, and then more mineral wool, and yeah, it's basically a concrete building with various forms of insulation and a larger style of VRF heating and cooling system with small Renew Air ERVs. And then they've got actually PV and a micro turbine as well. And then this is back in Boston, 5-story, completed in 2017 with 28 units, part of a larger complex. But this is market rate housing, 2x8 walls, cellulose and rock wool on the exterior. Also using Mitsubishi air source heat pumps and HRVs. And they are using PV and close to net zero. Also went for a LEED for homes mid-rise platinum, and includes some commercial space, interior parking, and a cafe in addition to the housing units. And then this is Bayside Anchor in Portland, Maine, developed by the Portland Housing Authority, 45 units that are a combo of affordable and market rate housing. Here you've got a double stud wall with 100% dense pack cellulose, 3 inches of foam under the slab, triple pane windows. They also were able to just use electric resistance baseboard and no cooling ERVs. And then this also has 50 kW of photovoltaics on the top with some special features like kind of a community garden that also works to collect stormwater and process stormwater. And then this is our last project. This is under construction right now, so we've got a rendering of it, but Lebanon, New Hampshire, Tracy Community Housing, expected to be completed later this summer. And it's developed by Twin Pines Housing, 29 units of affordable housing. Also 2x6 walls, cellulose insulation with 4 inches of polyiso foam on the outside, air source heat pumps, electric hot water, pretty intense photovoltaic array. I'm looking forward to seeing this building when it's finished, but it's got wall-mounted PV as well as roof-mounted PV to get it all the way to net zero. So it'll be an interesting building to see. I think they're doing a tour of it in the fall, so if anyone wants to go check that out. So when we look at what are the main differences between passive house for multifamily versus single family, really does mean a somewhat different design approach if you're used to doing smaller buildings. You know, some of the things that we look at when we're looking at these larger buildings is a high density, higher occupancy rates per square foot can result in things like high humidity, higher plug loads, and significant internal gains from appliances and other systems in the apartments. The other thing is with the orientation, south-facing units may have very different heat gain than north-facing units, but unlike in a large building with or you know, an open floor plan type building, you may not have that much opportunity to kind of share heat back and forth from one side of the building to the other because of compartmentalization and the way your HVAC is set up. So it's not like you can steal the heat from the south side to heat the north side. But one of the great parts about doing these larger buildings is you have this lower ratio of square footage to shell. So it means with the mass of the building, you may not need those high levels of insulation and super insulated assemblies. So there are, you know, pros and cons, not necessarily pros and cons, but things that make it more challenging, things that make it somewhat easier in a multifamily situation. So we tried to look at what are some of the typical wall assemblies that folks are using. There are many different ways to put together a wall, and it's going to depend on the building size, you know, height, lots of different aspects. But here are a few fairly standard approaches. This one shows a 2x8 stud wall with fiberglass dense pack in it, using ZIPS system sheathing, and that's the air barrier, and then some exterior insulation, in this case, polyiso foam, and then a rain screen and siding. So, you know, some variation of this where it's, you know, the majority of the insulation in the cavity and then some continuous exterior insulation. That's a fairly common strategy for passive house wall assembly. Second option is one that's actually, this is from BuildSmart. This is a panelized wall system that comes pre-assembled with windows actually pre-installed. So you can kind of have whatever framing you want on the you know, you can frame your building however you want, whether it's 2x4s or 2x12s. And then the panels come with the air barrier towards the inside, then a layer of continuous EPS foam, and you can specify how thick you need that to be to meet your requirements, but they can go from 2.5 inches all the way up to nearly a foot. And then you've got a layer of zip sheathing on the outside for your weather barrier sheathing, and, you know, windows and doors already installed. So that's one strategy to get to passive house wall assembly. And then this is another one that's from a Canadian firm that's been doing some passive house projects up in Vancouver area on the west coast of Canada, but shows kind of a more typical commercial wall assembly with cladding, fiberglass area, and a layer of foam kind of towards the middle of the assembly, your air barrier towards the middle. So now let's talk a little bit about kind of some of the lessons learned from the project teams and the case studies that I mentioned previously. And for those of you who are on a team, kind of what are the things that are worth thinking about as you start on your project? So we really strongly encourage an integrated team approach, which means bringing together the design team, the engineering team, general contractor, any key trades, your passive house rater or certifier, and really bringing as many of those people to the table early on in the design process. Because I think one of the lessons that we learned from talking to folks is a lot of the construction challenges could have been avoided if it had been brought up earlier in the design. So in that design phase, really being clear about the continuity of your critical barriers. That's your air barrier, your weather resistive barrier, thermal barrier, vapor barrier, and in all the design drawings, really labeling those clearly. I'll show some examples of that, but having either colored lines or dotted lines that clearly show where the air barrier is in each section. We recommend working with a mechanical engineer who has experience with low energy buildings. Oftentimes there is a tendency to oversize equipment, and actually a lot of these types of mini splits and things like that will perform worse when they're oversized, and that can actually be an issue for your energy model. So trying to work with someone who has done this type of thing before will really help. Also, like I said, consulting the trades during the design process to identify any issues related to constructability, and making sure that they're familiar, or at least helping to familiarize them with any unusual materials or equipment that you might be using. In cold climates, paying attention to the location of your compressors, and in keeping them out of the snow. I've seen some crazy pictures of compressors covered with 3 feet of snow. They're not working if they're covered with snow. So this project that you see on the right, we actually designed these kind of what we're calling mechanical balconies, but basically comes out of the mechanical room. There's a little protected area for the compressors attached to the wall. One of the things is paying attention to shading to prevent excessive solar heat gain. Another lesson learned was thinking about energy monitoring. This is not a requirement for passive house certification. However, if after the building has been operated for a while, the energy use is not matching your model, you're going to want to be able to investigate and figure out what's going on. And so organizing your circuits so that you can separate out hot water mini splits on one circuit, being able to go back and do some analysis and investigation, and track down the sources of energy use are really helpful. So think about that from the very beginning. And then have a plan for compartmentalization. So that's the unit to unit air tightness. What passive house, when we do the blower door test, we're testing the overall envelope of the building. However, they also, for Energy Star, require apartment testing. And often, it's trickier than you think it's going to be in terms of how the units may be connected through the floor trusses. So just making sure that during design you're planning for that, to really be able to separate. And that's also addresses, odor issues, not having cooking smells travel from apartment to apartment, and really, pests. There's a variety of reasons that Energy Star really puts that emphasis on compartmentalization. And then the last piece on the design side, really thinking about the maintenance of this equipment. I've seen some pretty crazy installations for, say, ERVs, like hidden in the top of a closet, where there's no way that you can really get at to open up the unit. These, both the mini splits, ERVs and HRVs, they have filters that need to be changed on a regular basis, like once or twice a year. Or at least checked on that kind of basis. And so thinking about, in these apartment buildings, how are you going to have access into the units if you have to change filters in the units? Or how can you design it so that the filters are accessible from mechanical room or common space, so that make it easier for the maintenance staff. So that's definitely something to think about. And some of the biggest failures we've seen are when those filters have never been changed, and you realize, the reason why you're not getting any heat is because it's like totally clogged up with cat hair or something crazy. So those are design phase lessons learned. When we get into the construction phase, we're really pushing for the idea of kickoff meetings with all, everyone on the team for that phase of the building. And so that means like for the envelope kickoff, you'd have the framers there, you'd have whoever's installing the windows and doors, insulation subcontractor. And at those meetings, it's just a chance to go over the drawings with everyone, talk about the air sealing strategy, make sure that everyone's on the same page about, say, the flashing detail for the window installation. We really recommend building mock-ups or doing a sample window install that everyone can sit there and look at, and manufacturers can give you a thumbs up and say, yes, this meets all of our criteria. This will not void the warranty. So having everyone there to talk it through and make sure we're all on the same page at the beginning of each phase. So both kind of kickoff of the design phase, kickoff before construction starts, looking at envelope, and then kickoff another kind of MEP before mechanicals start to go in with all the mechanical contractors. We also referenced this before, but really knowing your air barrier, having those labeled really clearly on the drawings. And often teams will identify a particular person, or at least a particular crew, that is responsible for maintaining the air barrier. Sometimes you'll walk on a passive house site and you'll see signage posted all over the place, basically saying, like, before you cut a hole through anything, like, go talk to Joe. And that's basically, plumbers, electricians, they're used to being able to make their penetrations wherever it's most convenient. And they really need to be part of, this larger education about why we're doing passive house and what that means for them. And that means any hole that they make, like being able to close it up right afterwards. And whether that's their responsibility or someone else on your team, that needs to be really clearly laid out. Who needs to be going back and filling those holes. And on some of our projects, we kind of had a whole kit on the site, a big box, that's got cans of, just little cans of spray foam. It's got tape, it's got caulk, it's got like all the things that you might need to go back and close those penetrations. So they can't say that they didn't know how. And it's all like right there, easily available. We've talked about blower door testing a little bit, but there's typically a variety of stages during the construction process that you're going to need to run a blower door test. At the minimum, you'll be looking at one after windows and doors are installed to kind of look at the overall envelope. And that's a good place where if you want to use some kind of fog or smoke testing, you can do that to look at any sort of questionable areas that may have air leakage issues. And then after sheetrock, do another test for the compartmentalization, make sure that the apartments are sealed off from each other. And then usually right before occupancy, you'd run another blower door test to get your final numbers and make sure you are hitting the passive house requirements. One of the things I didn't say exactly before, but passive house requirements are a kind of a pass-fail. It's not like a score where you can just get a little bit less, but like if you do not hit the air tightness requirement, like you fail. So this is part of the reason why the blower door testing is so important, and kind of identifying early on if there are any issues around air tightness so that you can get in there and resolve them earlier rather than later. One of the other lessons learned relates to humidity. This is both during construction and during occupancy. Some of the projects I've been working on, we were building mostly in the winter, got windows and doors in, and still had concrete curing. We were slapping around joint compound paint. We were running temporary heaters, and we were generating a lot of humidity, and there was no place for it to go because the windows and doors were in and everything was sealed up. So just one thing to pay attention to is checking the relative humidity as you go, and basically, you may need to invest in temporary dehumidification, large-scale commercial dehumidifiers to control that. And then during occupancy, just as I said, because you have relatively high occupancy loads and small units, you may have issues with humidity. Both the ERVs and mini splits do help with reducing humidity, but those two together, may not be enough to do it on their own. So we recommend monitoring and being able to control the HVAC system to increase dehumidification if it gets too high. Basically, you're trying to prevent any mold and mildew issues and condensation on your windows. During the construction phase, another lesson is really working with local technicians. I mean, sometimes on these projects we have somewhat, new materials, new equipment, and you don't want to specify something that there's no repair person within 500 miles for. So just, encourage, the idea of trying new things, but also making sure that you've got someone nearby who can service and maintain that equipment. And then also documentation. So one of the roles of a passive house rater certifier is to come and visit the site during construction, but they can't be there every day. So the more you can take photos of different phases of the construction process, have those on file. If any questions come up later during certification, you'll be able to kind of whip those out and show them what was happening during that phase. So in terms of additional resources for finding out more, strongly recommend the FIAS website has a specific URL that's just for multifamily projects. So it's this multifamily.fias.org, and that has more case studies, different resources specific to developers, engineers, architects, and information about the certification process. Also, NAPHN, so that's the North American Passive House Network, that has a whole variety of resources. And here in Massachusetts, we've got Passive House Massachusetts. They're offering events throughout the year. They meet, public information sessions and lectures and things like that. So definitely worth getting on their mailing list if you want to find out more about what's happening with passive house projects in Massachusetts. So, any questions from the audience? I'll leave this open for a little bit. I don't see any that have come through yet.
So I think one of the questions people often have is what the incremental cost for multifamily passive house is. And I think we've actually got a decent amount of information now on that. So I think the earliest multifamily passive house projects have been in Pennsylvania. So they have 23 funded low-income housing tax credit projects, and about 2/3 of those are built at this time. So there's very good construction data there. Those have, on a square footage basis, the average compared to a non-certified passive house building per square foot are showing between a 0 and 2% incremental cost. Now that is a very big project, and there probably were things value engineered out in that. So that's not necessarily the same as the incremental cost associated with passive house, but it does show you it can be done. fairly well. I think when we talk to consultants who are in this field about the ranges that they see, they often are seeing that the incremental cost ranges between 2% and 5%. So on what I've heard is generally it's pretty easy to hit the 2% mark with a very simple building. No basement, no podium style, you're not having to carve out commercial space out of it, very simple roof line, those kinds of attributes. And as you get more complex, it gets more into the 5% range. So those that are in our Passive House Design Challenge, there are 8 awardees, and all of them believe that they can hit the 3% incremental cost or below number. And I will say, you know, there definitely are projects that have come in above 10%. I would say they tended to be fairly new at doing this. They often added Passive House very late in their design process. And there are a number of examples with very, very complex roof lines where the details were complicated.
Great, thanks, Beverly. We've got a couple questions that have come in so far. One was, how do you deal with humidity in a high humid, or very humid climate? That's a great question. I think supplemental dehumidification is definitely one option. I've seen projects where there were individual dehumidifier, like in-wall dehumidifiers in each unit, or also a place where they were installed in line with the ERV, and so that could be used to control humidity. But I personally haven't been involved in any projects that were in a super humid climate. I mean, most of my projects have been here in New England. The next question was, how are people handling trash chutes? And I don't have an answer for that one. I don't know that any of the case studies that we looked at included trash chutes, but I don't know that for sure. The next one is I noticed that all but one of the case studies is, quote, affordable. I assume that's because of subsidies to offset the added cost. What's available for developers not doing, quote, affordable housing? Beverly, do you want to touch on that at all?
Sure. I would say I think affordable housing, maybe because it's so mission driven, has sort of been a leader. It's not really because of additional subsidies, although there are, like Pennsylvania is far out there because they have a point ranking system for who gets tax credits that does reward Passive House. But Mass Save, so those who are going to be building in Massachusetts, is about to roll out an incentive program. I've heard they're going to have a launch July 1st. I've heard there'll be 3 sort of categories of costs. So early soft costs, things like a feasibility study to see what kind of things would be included in design and what kind of incremental costs might be associated with that particular building. And then I've heard that there are also early soft costs maybe related to helping to subsidize the cost of the modeling or extra time for a consultant. And I believe that would be paid at pre-certification when you hand your plans over to the rating agency and they take a look at it and say, yes, I think you've designed it. If you build it this way, it should meet Passive House standards. And then I think there will be a final payment at the very end if you actually certify to Passive House levels. But I think the details will be coming very soon.
Great, thanks, Beverly. Next question is, should GCs do their own blower door testing? That's a great question. I mean, I think typically the Passive House rater is at least involved in the blower door testing, wants to be there for the blower door tests, whether they are actually the one running the equipment or not. I think could be debated amongst your team, like who's the best equipped to do that. There are also, subcontractors that will come in, and that specifically is their job, is they just come in to do the testing and the report out. And so that's another option if your GC is not set up to do their own blower door testing. Next question is, do you find it hard to specify equipment that matches the low heating and cooling loads and still deliver the required CFM? Well, I feel like those are slightly two different questions, right? So one is about heating and cooling. So, can you find mini splits? Not to say that it has to be mini split, but most of these projects are using mini splits. Can you find ones that are low enough for your specific heating and cooling loads? Typically, the cooling load is not the driver here in New England. So yes, it can be hard to find ones that are small enough if you're doing individual mini splits per apartment. But then the second half of your question is about, and still deliver the required CFM. That has more to do with the ventilation side. So you're not always delivering your heating and cooling through your ventilation system. I don't know if there's what else to say on that one in particular. The next question is, what's the limitation on operable windows in Passive House? I don't know that there is any limitation on operable windows. Like you can only have so many. So I'm not sure if I'm totally understanding that question, but there are no limitations that I know of. And then the next one is there any plumbing or water heating efficiency requirements? You certainly need to have, the amount of energy used for heating your hot water is included in the overall energy model calculation. But I don't know that there's a specific plumbing requirement, or like it has to be X percentage efficient. So it's kind of just built into the whole calculation. So, okay, I see, yeah, another clarification. In earlier Passive House requirements, operable windows were not allowed. I don't believe that's true. I think a lot of these projects have operable windows that we looked at in the case study. So either that's something that changed or just isn't part of the current requirement. All right, any last questions here? That's all I've seen so far, but happy to take any last questions before we finish up. The one thing that I'll just say is that we do have training credit available for this webinar through Passive House Massachusetts, and it requires that you just fill out a short quiz. It's about 10 questions that goes through the content that we talked about on this webinar. So you got the link in your registration confirmation. You'll get it again tomorrow just in case you missed it. Here's the URL if you to go to SurveyMonkey and complete the quiz. If you answer at least 80% of the questions correctly, you will get a certificate sent to you. And if you score below 80, you can always watch the webinar again and redo the quiz. We are going to be posting the video of the webinar to make that available to everybody through MassCEC. So give us a little bit of time to get that sorted out, but we've recorded it and we will post it afterwards. All right, Beverly, is there anything else on your end, or are you ready to wrap up?
No, thank you, Kate.
Okay. Well, thanks everybody for attending, and look forward to seeing your Passive House projects sometime soon in the future. Thanks.